Hello dear viewers. In these videos you can get acquainted with the experimental measurements of the electromagnetic background on a prefabricated sensor made of ferromagnetic materials and inductors. On the splash screen photo you see this prefabricated sensor. It is made up of H87 ferrites and koolMu blocks, linked by magnets with the south pole up. Lower coil 2.9 kΩ 2.5 H. Upper coil 1.56 kΩ 2 H. Permanent magnets can improve reception, as in the case of amplifying the RF field detected by a ferrite with a magnetized coil. The anomalous magnetic field, the cards of which are shown in the intro, in this location have a positive potential. Probably, when the magnetic fields are co-directed from the ground and in the sensor, then the reception will be amplified. The coils are connected to the line input of the PC sound card. The recording is made in the Spectrum Lab program. The left spectrum refers to the top coil, the right one to the bottom one. Frequencies 0.03 to 0.3 Hz and 0.3 to 3 Hz. Wavelengths 1 to 10 million km and 100 to 1,000 km belong to geomagnetic pulsations. Frequency 3 to 30 Hz. Wavelength 10 to 100,000 km. Research in the interests of communication with underwater and underground objects located at great depths, hundreds of meters, is underway. Frequency 30 to 300 Hz. Wavelength 1 to 10,000 km. There is the main part of the electromagnetic spectrum of power networks 50/60ths of a Hertz. In this range are the frequencies of the US Seafarer Communication Complex, 78 Hz, and the Domestic Zeus Complex, 82 Hz. Created for unilateral transmission of information to strategic nuclear submarines patrolling in the waters of the world ocean. Frequency 300 to 3000 Hz. Wavelength 100 to 1000 km. In this range there are electromagnetic oscillations of the sound range, the so-called whistling waves, whistlers, as well as various interference from household appliances. Frequency 3 to 30 kHz. Wavelength 10 to 100 km. This range has also been and still is in demand in signal transmission systems for reference frequencies, accurate time and meteorological information. In long-range radio navigation systems, including alpha and omega systems, for the transmission of synchronization signals, emergency alerts, etc., while at the level of transmitting complexes. Often combined with communication complexes with submarines. Recording was carried out in Krasnodar. These recordings can help you better understand the various methods of receiving electromagnetic fields up to 24 kHz. Below are links to various similar observations. Thank you for your attention.